Hi, my math friends. This video goes along with lessons 16 and 17 of our first module of sixth grade math, but this is moving on to what we're kind of calling Unit 2, the second half of our big unit on ratios and proportional reasoning. Today's topic is how you can use ratios to find rates and unit rates, and then how you can use unit rates to make some really smart math statements about different sets of data. Let's start with an example. Angela and Julie enjoy swimming, and they often swim at a steady pace to burn calories. Angela can swim 1,200 yards in 20 minutes. Her friend Julie can swim 1,500 yards in 30 minutes. Both of these are rates because they're telling you how many yards in how many minutes. They're giving you a rate for how fast each person can swim. That is distance and time. Distance and time. That's a rate. The question is, who is the fastest swimmer? Explain how you know by finding their unit rate. Okay? Let's talk first about Angela. Angela can swim 1,200 yards in 20 minutes. That means her ratio is 1,200 yards to 20 minutes. And this is a ratio. This is a rate. Okay? But what we want to do is use those two things to find how many yards she can swim in 1 minute, because that will be her unit rate. Okay, and unit rate is what lets us compare two different sets of data. Well, I could do this by doing some cut in halves. I could take the 1,200 yards in 20 minutes, I could cut them both in half and get 600 yards in 10 minutes, which is 300 yards in 5 minutes. Okay, I could do some kind of reasoning through, some good number sense reasoning to solve this. Or I can say, hey, to get from 20 minutes to 1 minute, I would divide by 20. So on this side, to get from 1,200 yards to my blank number of yards, I can also divide by 20. If you can't do that in your head, you're always more than welcome to grab a calculator. 1,200 divided by 20 tells us that she can swim 60 yards in 1 minute. Now we're going to go to Julie. Julie's rate is 1,500 yards in 30 minutes. That means her ratio is 1,500 or 1,500 yards to 30 minutes. I'm going to find an equivalent ratio. Specifically, I care about how many yards she can swim in 1 minute. Because if I found her yards in 1 minute, I'd be able to compare it to Angela's rate and say who is faster. Well, to get from 30 to 1, I divide by 30, so I can take 1,500 and divide by 30 as well. If you can't do that in your head, you're welcome to grab a calculator. 1,500 divided by 30 is 50. So Julie swims 50 yards in 1 minute. So then the question is, who's the faster swimmer? Well, I know that if in the same 1 minute, Angela is going 60 yards and Julie is only going 50 yards, that Angela must be the faster swimmer. She's covering more distance in the same amount of time. Let me remind you of our important vocabulary words. This up here is the rate. It tells the speed at which they're swimming by giving a distance in an amount of time. When I switched it to be the word to, that is the ratio. That's what we've been studying for this whole past unit. But then when I switched it to be in 1 minute, that's taking me to the very important unit rate. Okay, the very important unit rate, because unit rate is always per 1. So I have per 1 minute. Our math curriculum also wants you to be able to state what the rate unit is. The rate unit in this case, since we're talking about how many yards they can go in how many minutes, is yards per minute. Rate units always have the word per in them, and it's just like the label, okay? It doesn't have any numbers. Rate units are just like the label, yards and minutes. So what I'm coming up with is yards per minute. Specifically, Angela swims 60 yards per minute, and Julie swims 50. And then here's her rate unit, yards per minute. Okay. I hope that makes sense. Let's do another one. Bob likes to run. He can run laps around a track in 4 minutes. Specifically, he can run 5 laps around a track in 4 minutes. Here's his ratio. 5 laps to 4 minutes. Now let's state his rate. His rate is 5 laps in 4 minutes. Okay, they're almost exactly the same. Ratio and rate, they're almost exactly the same. But now to find unit rate, I need to turn this from 5 laps in 4 minutes to how many laps can he run in 1 minute. Because in order to find unit rate, it has to be per 1. Okay, unit rates are always per 1. Well, to get from 4 to 1, I divide by 4. So over here, I can also divide by 4. 5 divided by 4 is 5/4. This really says 5 divided by 4, or 5/4. If you wanted to simplify, that's 1 whole and 1/4 more. But 5/4 is just fine with me. He runs 5/4 laps in 1 minute. He runs more than 1 lap, but specifically he runs 5/4 laps in 1 minute. It's 1 and 1/4. Now, the great thing about this unit rate, here's our unit rate of 5/4. That unit rate is exactly the same as the value of this ratio. Think about it. We talked a lot about the value of ratios. The ratio is 5 laps to 4 minutes, or I could write it like this: 5 laps to 4 minutes, which means that the value is 5/4, or 1 and 1/4. The value of the ratio is always the same as the unit rate when you start with the rate. See that? How they're exactly the same. Let's do one more. Chris has a summer job mowing lawns. He can mow lawns at a constant rate of 2/5 lawns per hour. Okay, 2/5 lawns per hour. This 2/5 right here, friends, is the unit rate. They already gave it to us. And this part right here, lawns per hour, is the rate unit. They already gave it to us. So the first question they ask is, what is the ratio of lawns to hours? So now I'm taking this new rate information and kind of going backwards to the ratio. Well, I learned in the last problem that if I know the unit rate, that the unit rate is the same as the value of the ratio. I'm going to say that again. The unit rate is the same as the value of the ratio. Let me pull up the last problem that we did. Here was the ratio, 5 to 4. I wrote it in ratio, the ratio type that looks like a fraction, 5 to 4, which means the value is 5/4 or 1 1/4. And that happened to be exactly the same as the unit rate I had already found. So here, if they're telling me that the unit rate is 2/5, then the ratio is not 2/5, but 2 to 5. You just take the same unit rate, but you read it like a ratio, 2 to 5. So then the question is, how many lawns can Chris mow in 10 hours? Well, right now he's mowing, 2 lawns in 5 hours. So I could draw a tape diagram or a bar model. Here's his lawns. Here's his hours. 1, 2, 3, 4, 5. And if I care how many lawns that he can mow, so I'm looking for how many lawns can he mow in 10 hours. If I have 5 boxes and the whole bar is worth 10 hours, that means each box is 2. So up here, each box is 2. So the number of lawns he can mow is 4 lawns. 4 lawns in 10 hours. There's his rate, okay? But the answer to the question is this 4 lawns. How many lawns can he mow in 10 hours? Well, I have my ratio, 2 lawns to 5 hours. So I used it to draw a bar model or tape diagram. Here's my 2 lawns and my 5 hours. But then it said, what if the lawns is 10 hours? What if the whole hours bar is 10 hours? How many lawns would it be? I found my C number and solved. I can do another one similar to that. This time it's asking how long does it take Chris to mow 20 lawns? So I'll draw my bar model or tape diagram again. My ratio is 2 lawns to every 5 hours. So here's my 2 lawns. 1, 2, 3, 4, 5 to my 5 hours. And it says, what if Chris is mowing 20 lawns? That means this bar is 20 lawns. It wants to know how long it takes, or how many hours is it. If the whole lawns bar is 20, each box is 10. My C number stays the same. Each box is 10. So the number of hours is going to be 10, 20, 30, 40, 50 hours of work to mow those 20 lawns. This is 50 hours. 50 hours of work to mow those 20 lawns. But I solved this problem because I understood that when it gave me a unit rate, I could turn that unit rate into a ratio, and then I could use the ratio to solve the problems. I hope that that helps. I'm going to do a link for you for your video homework response form. Be sure to click it and answer my 2 questions. Thanks so much. Have a great evening.